you. I'm very pleased to be here today, and I hope I can provide some foundational information for you all. I have provided a written form of my testimony for your future reference, as well as a cheat sheet with all the figures. Science, we like to have a lot of numbers and figures to refer to. I want to focus on three things today, though. First, the disruption of climate patterns globally, the root causes of these disruptions, and the actions that we need to consider taking here in Vermont. So I'll start with what I've labeled figure 1. This is a figure that you will see in many global and national reports, such as presented by the IPCC and the National Climate Assessment. And what it shows is increases in carbon dioxide concentration over time, as well as changes in average global temperature. Obviously, there is a correlation there, but perhaps if you're a scientist, you would say, is correlation really causation? And in fact, what scientists have done is actually looked at radioisotope chemistry. That is, using the signatures of the type of carbon in that CO2 to actually fingerprint its source. And we can definitively say that not only is carbon dioxide increasing in the atmosphere, but it's coming from the burning of fossil fuels. And we focus on carbon dioxide because it's the largest of the heat-trapping particles that humans emit into the atmosphere and the most rapidly changing of those. So not only do we see that it's caused by the burning of fossil fuels, but we see that it's rapidly increasing in our atmosphere, and as it traps heat in our atmosphere, we see the global temperatures in our atmosphere rising. And in fact, there was an excellent publication in 2013, a peer-reviewed scientific article by Cook et al. In Environmental Research Letters. They surveyed almost 12,000 scientific publications released between the years 1991 and 2011. And over 97% of the authors of those articles agreed that climate is changing and that it's caused by human activities. So, just to represent the scientific consensus, it's very, very strong. In figure 2, you'll see, as I mentioned, that carbon dioxide is the largest of the greenhouse gases that humans are contributing to the atmosphere. And I would like to point out that energy use of fossil fuels is the largest source of these emissions. So in some ways, if you're thinking about policy, this provides some evidence for where we may look to start to mitigate or minimize our contributions to CO2 to the atmosphere. So with that in mind, we can then think about what this actually means. It's one thing to look at a global temperature, but it's something different to think about how this really impacts your lives. In figure 3, I've provided two figures. One is a map of the United States, and it shows the change in temperatures over the last century across the United States. And as you can see in that figure, almost every region of the United States has had increasing temperatures. There is some variability, but almost everywhere has gotten warmer. And I've also provided a graph in black and white that shows changes in temperatures across Vermont. What I've plotted here are the observations from the National Weather Service at stations in Vermont that have existed for the long term, have good quality data, and that are in lowland areas. So I'm not accounting for mountain effects, for example. And what we see is that we have a steady increase in temperatures across Vermont. And in fact, since 1990, temperatures in Vermont have increased about, on average, 1 degree Fahrenheit. Some areas more, some areas less. If you look at the Vermont Climate Assessment, which I provided a link to in the written form of my testimony, you'll see that we actually provide further analysis into when these temperature changes are occurring. And some of the troubling things are that this warming of temperatures is often happening at nighttime. What does that mean? It means in the summer, when we have a heat wave, that it's not cooling off as much as at night. You've perhaps considered buying an air conditioner, or you've seen more around your town. This is because we're not cooling off in the nighttime, and that starts to become a public health problem. And in fact, when we see nighttime temperatures over 85 degrees for several days in a row is when we start seeing higher incidence of heat-related hospital visits. So this has real impacts in Vermont. We can also think about precipitation, how it affects us as a country and how it affects us in Vermont. So as temperatures rise in the atmosphere, a secondary effect is that we get more water driven into the atmosphere. That puddle on the sidewalk evaporates faster when it's hot, and we get water vapor in the atmosphere. Not only does it cause additional warming to the atmosphere, but it also makes some places get more precipitation. In New England, we can see the Northeast has gotten much more precipitation over the last few decades. And in fact, across Vermont, we've seen on average a 10% increase in precipitation since the 1960s. Some areas like Mount Mansfield has actually seen a 20% increase in precipitation. If we think back on this national map, you might start to think about where your winter vegetables come from. I know I see a lot of fruit in Vermont grocery stores from Florida, a lot of our vegetables and produce coming from California in the winter, as well as our reliance on the Midwest. So as temperature and precipitation begins to change in those regions, you can also think about what ramifications that has for us. Sure, we don't live in Florida, but we certainly depend on goods and products, services provided by those states to us as part of our national network of food security. And as you all know from our own experiences with flooding here in Vermont, flooding is a big concern because it renders a food crop unusable. It has to be foregone for health and safety concerns. What I think is most concerning about the increasing precipitation is shown in Figure 5, and that is that not only are we getting more precipitation, but it's coming in very large events. So the figure that I plotted here is from Rutland, and Rutland and southern Vermont is more extreme in terms of the number of storm events they are getting. That is, all of Vermont is seeing this precipitation fall in more calamitous storms. So we're getting more rain, but it's coming in shorter time intervals. We're getting days of more than 1 inch of precipitation. That's a lot of rain. We're getting more of those days across the state. And in Rutland, we see that in the 1960s, we had about 4 or 5 days per year that have more than 1 inch of precipitation. And today we're in the range of well over 10 days per year. That's a large change. And in flood-prone areas, this is a very high risk for flooding and other damages. In addition to these changes in precipitation, the changes in temperature that we've observed are also changing our freeze and thaw days. So while our growing season may be increasing, we also see a decrease in the amount of time we have frozen, which is a concern to thinking about the natural communities in Vermont and how they depend on some of these freeze-thaw cycles. Maple sugar, I would say, is one of the most iconic components of our natural ecosystem. And people think of Vermont, they think of maple syrup, they think of skiing, they think of winter recreation. And as we have more variability in terms of winter length and the quality of the winter season, this becomes a real challenge for Vermont. So for example, we might still have a nice cold winter, but if more of that precipitation is falling as ice or freezing rain, it's not the same quality experience that we tend to provide to other areas. Another interesting teleconnection to note for New England is that Vermont receives the most winter tourists when it's snowy in New York and Boston. So as we see less snow in New York and Boston, we may expect to receive less tourists here without interventions to try and entice them to come to Vermont. In Figure 6, I wanted to point out a map. This is satellite-derived temperatures across the globe for February 2015. And what it's showing you is areas that are above normal and below normal as compared to a 1960 to 1980 baseline. So we've had a very cold winter. And as someone who's only lived in New England about 10 years, I would say this is below average. If we look back 30 years, this was a very average winter for Vermont. So it's showing you that our baseline has shifted. We are having, on average, warmer temperatures in the winter, and this year seems more extreme. However, if you look at us in the national and in the global context, we are the only cold patch on the world. This is one of the warmest, if not the, we'll see, the data is still coming in, but it may be the warmest winter on record across the world. So it's important to keep in mind these contexts, both the historical context and how we fit in this bigger picture. I've also included a few examples that maybe are more personal about climate change. So we can have a meteorological station sitting out, at the National Weather Service, but the stories that really resonate with me in Vermont are those of people who observe changes in climate. And when I talk to people who've lived in Vermont their whole life and I ask them what changes they've seen, they can tell me how things have changed. So for example, Ray Allen of Allen Home Farm in South Hero can describe how the McIntosh apples on his farm bloom earlier. And not only can he describe it, but he made a written record every year of how the bloom date changed on his apples. He's also a co-op observer for the National Weather Service, so we have the weather data, and we can see the correlation between warmer, earlier springs and the earlier blooming of his McIntosh apples. And when I first met Ray, I said, wow, isn't this great? You have a longer growing season, and maybe you'll get more apples. And since then, he continues to tell me every time I see him some of the challenges that he's having. For example, last summer, his trees set so much fruit that they didn't get very big, and he actually had to pick a lot of it off to try and encourage the apples to get big enough to sell as fancy grade apples to the grocery store. Also, when the springs come earlier and the trees bud at this time, it tends to be warm and wet, and the tree bud is like an open wound that allows fungal infections to enter the tree. So there's a much greater threat of damages to our apple crop by having an early spring, and that even outweighs the benefits because of the additional costs and labor required to try and combat these fungal infections. Additionally, Ray points out that his tractor often gets stuck in the mud when we have an early spring. I also love the example of Joe's Pond Association. Probably many of you have read about it in the news, perhaps even put in your own entry on when the ice will go out. This is a project that was really started for fun, but what we end up with is this really clear, very scientific, really, measurement of when the ice goes out. It's a repeatable experiment that's very reliable. And if we compare the date of ice out to the average winter temperature in West Danville, we can see that there's a strong correlation. Winter temperatures are getting warmer, and ice out is happening almost 7 days earlier than it was when they began this quote-unquote experiment in the late 1980s. So we have a lot of local evidence in Vermont, and as I have gone around the state and talked to Vermonters, they all have some story about how they think climate has changed, whether it's differences in how the sap flows on their farm, differences in the blooming of the trees, or ice out on the pond in their backyard. It's something that we can see and that we can feel. One of the key take-home messages that I'll leave you with from the Vermont Climate Assessment is that while these are challenges that exist, there are solutions that we know, and Vermont has the expertise to begin to address these challenges with climate change. Not only is it something that Vermont is poised to take a leadership role on and develop new technology and new independence in terms of our energy reliance, but it's also something that has an economic benefit to Vermont. And I would love to talk more with any of you at any point about these topics. But I would encourage you to check out the New Climate Economy Report, which came out of an independent group in Europe, and it was looking at the benefits of development using climate-friendly measures, such as encouraging public transportation, using green infrastructure for runoff and sewage and things like this. And actually, when you build communities that are more climate-friendly, they tend to also be more attractive for development, and therefore there's actually a long-term economic benefit that comes from taking those measures. So I would urge you to consider those benefits of acting on climate change. Thank you.
Thank you, Dr. Galford. Could I ask for your help in 2 ways? Could you send to our committee assistant links to the Vermont Climate Assessment as well as the Climate Economy Report?
Will do.
Great. Share them with the committee. We have a couple minutes for questions before we go on to our next guest. So, any committee questions? Senator Rogers.
I got one. I'm just interested in if human, I know that, I'm not a climate denier, And I know that we're releasing huge amounts of carbon that wouldn't be released if we weren't here. But if we weren't here and using internal combustion engines and burning coal and all the things that we're doing to contribute, would there still be an up and down in the world's climate cycle?
There would be changes in our concentration of CO2, I think is what you're referring to.
Like, some people say that a single large volcanic eruption produces as much carbon as humanity does over a long, long period of time. And I'm just wondering, how does it all balance out? And you say that we're the cause. I think we contribute. I'm not sold that we're the 100% cause.
I studied as an undergraduate as a geologist. I love questions about volcanoes, so thank you for that. It's true that volcanoes do release carbon dioxide into the atmosphere. That's very well known. I put in my testimony a few specific references that actually have quantified how much CO2 that is. And we are emitting 100 times as much as those volcanoes can contribute, even large events like the eruption of Mount Pinatubo. So the order of magnitude is extremely different. It's true that, for example, season to season, we see changes in CO2 concentration in the atmosphere. So when the northern hemisphere is in spring, we take up a lot of carbon in our trees, and in the fall we release it. So we see small squiggles in the concentrations of CO2. But for example, right now we've reached 400 parts per million CO2 in the atmosphere. And if we look back even hundreds of thousands of years, we're in the range of about 250. So we are orders of magnitude above what was ever observed in the geological time scale. Yeah. Great question. Thank you.